Good evening, everyone. My name is Meredith Toohey, and I'm the Conferences and Events Manager at the American Nutrition Association, the ANA. The ANA would like to thank our sponsor, Standard Process, for their support in bringing this webinar to you. Visit their website, standardprocess.com, to learn more about their dedication to the field of nutrition and whole food philosophy. The American Nutrition Association is very pleased to be hosting Dr. Jennifer Stagg tonight to explore the endocannabinoid system and its role in human health. Welcome, Dr. Stagg.
Hi there, thanks for having me. For those of you who don't know much about me, I'm a naturopathic physician. I have a clinical practice in Connecticut. My background is in biochemistry, nutritional biochemistry. And so, I'm really excited to be a part of this webinar series. So this focus is on the endocannabinoid system, and I'm going to talk a little bit more extensively about the role of hemp oil and certainly the endocannabinoid system, but also the role of omegas in that as well. And so a lot of us are are hearing quite a, certainly I'm sure some of you may know a lot about the endocannabinoid system already. If not, it would be a surprise if you haven't heard about CBD oil or hemp oil. And so tonight I want to really focus on the role of the endocannabinoid system in inflammation, specifically to immune balance. And as we know, inflammation is really the foundation of a lot of chronic disease. The endocannabinoid system is really part of one of your systems that helps to regulate your entire body system. So that role of homeostasis is really important here with the endocannabinoid system. And I don't think, for me, when I first learned about this, I wasn't aware of it. It wasn't a part of our medical training. We certainly, as naturopathic physicians, learned a lot about homeostasis, and a lot of what we do is to help our patients get a better handle on achieving balance in their body. So I definitely want to review that role during this webinar. Also talk about the unique distribution of some of the cannabinoid receptors in the body, CB1 and CB2 receptors. Also explore back to that inflammation and endocannabinoid system and how these two systems interact, and the role of hemp oil and omegas, and specifically omega-3s, and understanding the legal status of hemp oil supplements. So let me go ahead and start with that. Hemp oil, for those of you who are not aware, is not, obviously, I think a lot of people are aware that hemp oil and marijuana are two completely different substances. These two types of products are derived from the cannabis sativa plant, but they're different varieties. Hemp oil is legal in all states if it meets two criteria. So the criteria is that the hemp oil is derived from the stalk and seeds and not the flowers and the leaves, because those are higher in the psychoactive component, THC. And hemp oil also must require, in order to be legal, that it contains less than 0.3% THC. And you're going to see that in hemp oil products because they're extract of the stalk and the seeds. So when it comes to systemic balance and homeostasis, I want to spend just a little bit of time with a little bit of a reminder about that and the role of the immune response and healthy inflammation. So obviously when a system is balanced, the balance is on stress management. When you are managing stress in your environment, because we're all exposed to stressors, when you're managing that well, you'll have systemic balance, and that results in a very healthy inflammatory response. So if you had a stress in your life, like trauma, your body's able to, a physical trauma, your body's better able to respond to that physical trauma, whether it's a cut, an injury, and can mount a healthy inflammatory response and resolve inflammation. I'm going to talk about that a little bit further in this webinar. And then get back into homeostasis, which is the ability to resolve inflammation. And then kind of, you know, when a stressor comes up again, we can work through that whole cycle again. When it comes to a system that is imbalanced, and these all kind of run into each other, if your body is affected by stressors, and this could even be chronic emotional stress. It can be poor diet is a stress that the body is affected by, and also even environmental toxic chemical stresses. So all these nutrient signaling pathways are coupled, and there's a lot of crosstalk between these systems. If the body has an imbalanced inflammatory system, there will be autonomic imbalance, and that cycle of stress kind of continues to go on, and your body never has an ability to regulate inflammatory responses and be able to better manage stress. And why this is important is that the endocannabinoid system is involved here. And like all the other systems in the body, the endocannabinoid system can be thrown out of balance from stresses and traumas and toxins. So a lot of people don't necessarily think about the endocannabinoid system in that way, but I just want to really highlight that the ability to mount a controlled and balanced stress response does involve the endocannabinoid system. And that's why we also see that people, and this is not, you know, a hard and fast rule, but as a trend, as people age, their endocannabinoid system gets more out of balance. And I think we see that in many hormonal systems as well. But in clinical practice, we'll see that patients who are good responders to phytocannabinoids tend to be a little bit older. So younger adults often don't have as strong a response as older results. Not to say that it can't be of benefit, but there is that sort of profile that as we get a little bit older, and I'm not even talking about, you know, not a little bit older doesn't mean that even children could benefit from, as we know, the only cannabinoid-based pharmaceutical is for the treatment of epilepsy in children, to specific types of epilepsy. So that's sort of just related to the imbalance. All right, so let's get into the receptor system a little bit further. So, and let's get an idea of really what's going on at a deeper level within the body systems. So when we talk about the endocannabinoid system, these endocannabinoids also regulate neurotransmitters. They regulate the HPA axis and have a role in immunity. The endocannabinoid system was discovered in 1992, and it has been shown to be present throughout the entire body and can regulate a vast array of function. So as you can see here, the distribution of the two major receptor types, these specific cannabinoid receptors, CB1 and CB2, are a little bit different. So the immune system is primarily filled with CB2 receptors. There's some CB1s, but most of it is the CB2 receptors. And we know that these CBD is also kind of interestingly, and we'll talk about this a little bit more, that when those receptors are bound, and I should point out that there are two different ways these receptors can be bound, or I should say three. Phytocannabinoids, and those are going to be plant-based cannabinoids. This is what you would see in hemp oil, or when you're CBD, for those of you who are not aware, CBD is cannabidiol. So it's a specific type of phytocannabinoid that is found in hemp oil. And then there's the endocannabinoids. So we actually do make some cannabinoids in our body, and those cannabinoids are made primarily from conversion of omega-3 fatty acids, and I'll talk about that also. I have some slides on that. And then there are synthetic cannabinoids, and I will talk about one of those in this webinar as well. The endocannabinoids that are in our body are just these lipid signaling molecules, and those can elicit physiological responses through those specific cannabinoid receptors. So those combine the CB1 and CB2 receptors. And depending on the type of receptor that's bound, how strongly the receptor is bound, they play different roles in terms of function, which some of the functions that are regulated throughout the body include sleep regulation, even appetite and GI function, things like gastric emptying. Motility is also controlled by the endocannabinoid system. Insulin regulation involves endocannabinoids. And then when we start to look into the nervous system, there's data showing regulation of mood, of memory, regulating pain, the reward system even. So when you think about like dopamine and neurotransmitter function there's so many different systems that are affected by endocannabinoid function. Even, so much metabolism and even mitochondrial function. All mammals have an endocannabinoid system, and I really want to point out that it's a really integral system to achieving homeostasis. So these CB1 and CB2 receptors have different distribution effects in the body, as I said. This slide, I'm looking at it, I think there's a little bit of an issue with the slide, unfortunately. The CB1, that activation of, I think it was CB2, there's an error on that slide. So I'll just point out what that is. So suppression of CB1 receptors. So as I said, depending on what that substance does to the receptor, whether it blocks the receptor, whether it weakly binds the receptor, or strongly binds the receptor, you can see different outcomes depending on even the location of those receptors in the body. So suppression of CB1 receptors, which we do find quite a bit throughout the nervous system, have been shown to decrease food intake and decrease depressive disorders. So, I'll talk about that in a second as well, about how there was a medication that was developed as a result of this data. The activation of the CB2 receptors does decrease neuropathic pain and decreases nausea and anorexia as well. Oops, sorry. Okay, sorry, I just didn't complete the slide. So it is there. So the CB2 receptor does decrease bone loss, it decreases inflammation, it decreases neuropathic pain. So that's the activation of the receptor. And then back to the CB1 receptor, if you're activating it versus suppressing it, you have some different effects happening there. Back on that topic of activation and blocking of receptors, the CB1 receptor, there was a SNP, a single nucleotide polymorphism, that was reported to be associated with less fat intake and higher carbohydrate intake in obese females. So there was some thinking based on that to develop a medication that could potentially help with obesity, of course. So with this specific SNP, the ancestral SNP is GG. And in that case, people ate more fat, they had higher BMI, but they had lower levels of adiponectin. The mutant polymorphism, the GA or AA, showed a lower BMI. It was protective, had a better lipid profile, has a better lipid profile, and lower intake of saturated fat and cholesterol. So with that, there was the development of a selective pharmaceutical that targeted the CB receptors. And so obese individuals display this increase in CB tone had been shown to, and were displaying a chronic activation of CB1. So the thinking was to block that CB1 receptor, and this medication was developed and only went on the market in Europe in 2006, I believe. And it was a CB1 antagonist called rimonabant. It was approved for the treatment of obesity, but it ended up it never passed FDA regulation here in the United States, and was withdrawn worldwide due to serious psychiatric side effects. So herein lies the problem of targeted receptor activation with a specific compound that works on this one specific type of receptor in a specific area. What happened, some of these psychiatric side effects were quite severe, showing depressed disorders and mood alterations in up to 10% of the population on the medication. And there was also suicidal ideation in 1%. Also seen, interestingly, and certainly not surprising, as I just reviewed how many different systems and effects can be displayed from activating these receptors. You can't just, expect one result in terms of, food intake. Also seen in terms of adverse effects were nausea, upper respiratory tract infections were really common. And then there were also issues with people developing irritability and anxiety, having gastric side effects, insomnia and sleep disorders, hot flashes, muscle cramps, spasms, fatigue, flu-like symptoms. The list went on. So that medication got pulled from the market and was not effective as an obesity medication. But it really does highlight the importance of having a more broad spectrum complete whole extract like hemp oil, which we don't see coming with that set of adverse effects. So when you balance out the CB1 and 2 signaling, that is the advantage of using an extract like hemp oil. When you use hemp oil, you will see hemp oil can act as an antagonist of CB1 receptors. It can decrease food intake, can improve metabolism. As an agonist of the CB2 receptors, it can decrease bone loss, it can decrease inflammation. And there are a lot of other compounds found in hemp oil other than just phytocannabinoids. It's also a good source of omega-3s. And as I'll show you, omega-3, these polyunsaturated fatty acids, become precursors for endocannabinoids. So not only do they contain, in hemp oil, you will find various phytocannabinoids, you'll also find that it affects our production of our natural endocannabinoids. And it also affects upregulation of these cannabinoid receptors. So you see more broad spectrum effects when you use a whole extract. So hemp oil is a really good source of omega-3s. I'll even see it sometimes when I look up sources, best sources. You read these articles about best sources of omega-3s, and now you're seeing like hemp seeds on that list, chia seeds. These oils that are contained in hemp oil are also known to be precursors to the endocannabinoid system. So these deliver, not only are they delivering precursors to endocannabinoids, then we also just, as you're well aware, when we study the effects of omega-3s, there is this anti-inflammatory response and cascade that occurs there. So not only do you have the conversion to EPA and DHA in the body from the alpha-linolenic acid, you'll also see that there is that conversion to the endocannabinoids. And so listed there are AEA and 2AG, two of the more highly studied endocannabinoids. They're probably the most widely investigated endocannabinoids. And a lot of the data on endocannabinoids come, even though there's not a lot of data in the United States in origin, there is quite a bit of data existing over, the last couple of decades, I guess, out of Israel and Europe. So AEA is anandamide, and then 2AG is another compound that is highly investigated, thoroughly researched endocannabinoid. So when we look at the dietary role of polyunsaturated fatty acids, not only do those compounds can act as substrates for signaling molecules like the eicosanoid pathway, prostaglandins, leukotrienes, you also have the endocannabinoids there. And certainly we're all well aware of the effect of omega-3s on the receptors and also on the fluidity of cellular membranes, ion channel function signaling, and protein localization. And then that obviously goes on to affect organ systems. Sorry. I do also want to point out that not only omega-3s can affect the the endocannabinoid system. There are some, I don't have a slide on this, but I do want to point out that some of the clinical interventions that we characterize as being complementary or are characterized as being alternative medicine also have the ability to upregulate the endocannabinoid system. So there are a lot of physical medicine, massage, spinal manipulation, acupuncture have shown to be have effects on the endocannabinoid system, just those on their own. So it's not just like oral, and there are certainly some other herbal medicines that can have some effect on this system. But physical medicine can also be delivering some of the immune balancing and homeostatic effects through the endocannabinoid system, which I found to be really fascinating, because we consider those modalities to be helpful in terms of regulating systemic balance. And I guess, in my training, I wasn't completely in understanding what the pathway was. I'm always looking for what the pathway is. And it appears some of the effect that those modalities have are actually through the endocannabinoid system. Also, there's also evidence that several classes of pharmaceuticals can have effects on the endocannabinoid system. So some of the mood-regulating medicines, antidepressants, antipsychotics, anxiolytics, anticonvulsants even, can have effects on the endocannabinoid system, and analgesics, NSAIDs, acetaminophen, opioids, glucocorticoids also have been listed as medications that can impact the endocannabinoid system. So you have medicines, we have complementary alternative medicine modalities, and then even lifestyle modification, which is at the core of everything I do with patients on a daily basis. Diet, maintenance of weight, exercise. These are all modalities that can affect how processes that can affect the endocannabinoid system and your ability to better achieve homeostasis. So that's how some of those lifestyle interventions, how well how physically active you are, does affect the endocannabinoid system. So EPA and DHA on their own don't directly interact with the cannabinoid receptors. What happens is that these are precursors for, and I kind of pointed that out before, these are precursors for compounds that do interact with the cannabinoid receptors. There are also cannabinoid enzyme systems. The main one that's studied is an enzyme called FAAH. fatty acid amide hydrolase. And that particular enzyme system is affected by omega-3 intake. And those enzymes are responsible for breaking down excess endocannabinoids within the system, specifically the anandamide. So these endocannabinoids that I listed here, DHEA, and this is not the steroid hormone, it's a separate compound, DHEA, docosahexaenoyl-ethanolamide, and then EPA have been shown to have a high binding affinity for CB1 receptors, acting as partial agonists. There's also the ability for these omega-3s to regulate the CB1 and CB2 receptors. So in response to the intake, tissues respond by increasing the level of receptors that come up onto the membranes of cells. So we're all pretty familiar about this omega-6, omega-3 pathway and the pro-inflammatory cascade, and then the omega-3 cascade that leads to more of like an anti-inflammatory pathway. DHA and EPA are the compounds that we're all well aware of that influence that pathway that are anti-inflammatory. And that pathway also influences the resolution pathway, which I'll get into. This slide here, this slide here, the effect of hemp oil on specific CB1 and CB2 receptors. This one is activation in vitro. So this was not done in a human study. That slide, unfortunately, is missing the dose of hemp oil, but this was increasing doses, and you can see the hemp oil does have binding affinity to CB1 and CB2 receptors, and unlike a pretty strong binding affinity, and so increasing dose doesn't necessarily show a vast increase in the binding of those receptor types. But you can also see there that CBD is on that list, and CBD on its own at the same concentration doesn't produce as much effect as hemp oil does. And then you also see the effect of EPA and DHA, which we have long known to be anti-inflammatory. And I think CBD is touted as primarily an anti-inflammatory, inflammation-driven solution. And all of us in the nutrition world know that EPA and DHA are long held as important in the inflammatory cascade, and we can really see that here reflected in this slide. So moving on a little bit further into the inflammation pathway, which I really wanted to highlight during this webinar, that supporting healthy initiation and resolution phases using the omega-3s that are that we're all familiar with, but also omega-3s that are found in hemp oil can affect inflammation response. So the inflammatory response is well defined at this point to be essentially two different phases. So you have the initiation phase, where that is the acute response immediately following, if we use the example of a trauma. So someone, you get a cut, and right away you're going to have an acute inflammatory injury. There's swelling, there's neutrophil is the cellular infiltration that happens. That's a cell type that responds to an acute situation. And the inflammation then should proceed on the timeline through the resolution phase. And important for resolution phase is the transition from macrophages. So there's this macrophage switching, and this is a very active response where you go from neutrophils to macrophage, and that helps to resolve or complete the inflammatory response. when people are experiencing the effects of chronic inflammation, that is now understood to be difficulty, impairment with the resolution phase of inflammation. So it was once thought that the inflammatory response just sort of like fizzled out on its own, but it is a very active resolution phase. That is the part that if there is chronic inflammation, it's an issue with not being able to resolve that second phase that is driven by macrophage. So interestingly, and not surprisingly, knowing what kinds of responses you see in body systems when hemp oil is used, that CB1, CB2 receptors do have a role here in that inflammatory resolution phase. So we see macrophage activation by omega-3 oils. So there are these various compounds found in omega-3s, and then we also convert omega-3s to these resolving mediators inside our body. We have the ability to do that, and that in some people is more impaired and can lead to chronic inflammation. But you'll see compounds called resolvins, maresins, that are involved in that pathway. But 2-AG is what I would highlight on this slide. That 2-AG is one of the endocannabinoids that has an effect on these macrophages. And so the macrophage switching from an M1 cell to an M2 cell, the endocannabinoid has the ability to bind the receptor and downregulate that cell while also stimulating the M2 cell, which leads to the pro-resolving effects, which helps complete the inflammation phase. So not only do we see these omega-3s involved in this pathway, we also see the endocannabinoid system involved here. And that really helps us to better understand the effects of hemp oil in inflammation. So I do want to bring up antioxidants as well, because as I'm sure you're aware, oxidative stress and inflammation go hand in hand. The classic antioxidant that you may be familiar with is broccoli extract. So sulforaphane is a very strong activator of the NRF2 pathway. And the NRF2 pathway is the pathway that is what you'll see most described phytochemicals that have antioxidant activity, having the ability to upregulate. So as I said, oxidative stress and inflammation really go hand in hand. If you have inflammation, you're going to have oxidative stress. If you have oxidative stress, and oxidative damage, it causes tissue impairment, tissue inflammation as a result of that. So that's sort of a vicious cycle. So broccoli extract, is metabolized to sulforaphane via our gut bacteria. So when people are eating broccoli, which we know to be a superfood, it is an inducer of the NRF2 pathway, and that triggers this antioxidant activity. And when you trigger that activity, it also helps to block the inflammatory response pathway. So when we take a look at that antioxidant response element, that's what's referred to as the ARE, there are a number of different genes that code for mediators in this antioxidant pathway, and they're also important for the resolution of inflammation processes. So when you have a phytochemical come in and activate this system, the cascade you'll see is one that has the ability to upregulate NRF2 and have a strong antioxidant effect. So then let's just finish off with a case study. let me just point out though, the role of hemp oil. So hemp oil also has been shown to protect against free radicals. And hemp oil does have a high antioxidant activity. It's actually been shown to be higher than classic antioxidants like vitamin E or C, and it's thought to work through the NRF2 pathway as well. So moving on to the case study, I'm going to talk about a patient that came in who had a long history with generalized anxiety. She had really had kind of suffered from chronic worry, difficulty with resilience to stress, but this had progressed to panic attacks and trouble sleeping, and she was experiencing really severe PMS, so to the point where she had been diagnosed with premenstrual dysphoric disorder. She was experiencing symptoms of headaches on a regular basis, a lot of chest pressure. She had been fully evaluated and worked up and treated with actually been put on medication. So she was taking sertraline and lorazepam to help manage the anxiety, but she was still having panic attacks and this constant sense of chest pressure. In terms of supplements, she was taking magnesium, glycinate, and omega-3 supplements. We had tried a lot of different nutrient-based treatments, and certainly tried things, about modalities that helped her manage stress better, acupuncture, meditation, some of the supplements I listed here, taurine, B6, B complex. Before she was on medication, she had taken 5-HTP. We had done genetic testing. She had been had tested to have a SNP for MTHFR, and so she was taking methylfolate and had taken, a wide variety of herbs to help manage generalized anxiety. But this had progressed. There had been some time since she had seen me, and it had progressed, and she had gotten to the point where then she was taking prescription medications. So with all the data that was coming out on and what I was learning about using hemp oil, I decided she would be a great test case. She had been thoroughly evaluated, had already been on prescription medicine, and still was not getting relief. She had all of her labs were good, her thyroid was fine, and so we decided to use hemp oil because she had really tried everything in the past for generalized anxiety, and this was even worse at this point when she had come to me. So I had her continue the magnesium and the omega-3s. We were considering to do advanced genetic testing, but we thought we would just try the hemp oil at first, and she wanted to decline the genetic testing because she thought it was worth to give hemp oil a try, and then, later use genetic testing if we weren't seeing the results we needed. So she came back in 4 weeks, and in 4 weeks on hemp oil at 1 capsule twice a day, she had rated her anxiety symptoms as a 50% improvement. She had gotten to the point where she was reducing her use of lorazepam, so that was being used as a kind of a PRN dosing, and she was using a lot of it. So even in that 4 weeks, she had really greatly reduced the lorazepam, and then, having one menstrual cycle in that time frame, which was close to the time when she followed up, she had only 1 episode of extreme irritability. So we agreed at that point with such significant results to have her just continue on the hemp oil. We would wait for another menstrual cycle to see how she was doing with PMDD and follow up in another month, because 50% improvement is very significant to see. I didn't put in the notes here, but she did come back about that time, and she had again felt like the hemp oil was still working for her, and she had a little bit more improvement. And so that was a very good, it's only one case study, but it was significant enough to show that, that hemp oil was really beneficial in that case to help with regulation of mood. So I'd like to thank you for spending this time with me. I know how valuable your time is, and I really appreciate you taking the time out of your busy schedule to listen and learn more about the endocannabinoid system. Thanks.
Thank you so much, Dr. Stagg. This has been an enlightening evening, and we invite our audience to learn more about your work at drstagg.com. Good night and best of health to you all.